Okay, so this was actually your got it for number 5. So you could practice this one as well for problem kind of number 6. Uh, Yogurt quart allows you to choose 3 of 10 possible. So there's your N, there's your R, and mixing it doesn't matter how many different ways that you can do it, right? How many different just right smoothies are possible, right? So it doesn't matter. It doesn't matter if you put banana in first and then the strawberries, or strawberries then banana. Okay. So go ahead and try to figure out what that one would be. All right, now let's jump into problem number 6. Finding probability. So we have 3 pool balls are randomly chosen from the set numbered from 1 to 15. So what is the probability that the pool balls are chosen numbered 5, 7, and 9? Okay, so there's a few different things we have to look at here. So since we're finding probability, we want the probability of choosing, because we're trying to figure out how many ways we can do it, right? And the probability of that. So we're not finding the number of ways we can get 5, 7, and 9. We want to find what is the probability of getting a 5, 7, and 9. So that means first we have to find how many ways we can get 5, 7, and 9, and then use that out of the number of ways that we can get 3 different pool balls. Okay, so we want to find the probability of choosing 5, 7, and 9. So that means we need to know, you know, how many ways, so number of ways to get 5 or choose 5, 7, and 9. And then, so that's out of what we want, right? That's what we want. Number of ways choosing 5, 7, 9 out of total possible. Well, the possible is the number of ways to get 3 pool balls. Okay, so to find the number of ways to get the choosing 5, 7, and 9, well, we use the fundamental counting principle that says, okay, well, when we're choosing 5, 7, and 9, well, when we're choosing 5, 7, and 9, we have 3 choices, right? 5, 7, or 9. So the first ball that we get, so the first ball, I have 3 choices, right? And the second ball, I only have 2, because if I choose 5 first, then I only have 2 left, right? And then I only have 1 left. So it's fundamental counting principle is just 3 times 2 times 1, or 3 factorial. So there's our numerator, is just 6. Okay. Now our denominator is a little more complicated, because I have to figure out how many different ways can I get 3 pool balls. So 3 pool balls, again, does the order matter? So I got to kind of look at the question and see, does the order matter? 3 pool balls at random sets of numbers 1 through 15. What's the probability of the pool balls chosen numbered are 5, 7, and 9? So it says nothing about the order, so I can do 5, 5, then 7, then 9, or 7, then 5, then 9, as long as I get those 3 numbers, right? So order doesn't matter. So that's going to be, for the denominator, is going to be a combination. Okay, and how many numbers am I picking from? Well, I'm picking from 1 to 15, right? So that's 15 numbers. And then how many am I actually choosing? I'm only choosing 3. So then we can run through this, and I can go ahead and I can either go ahead and do it all out like this, 3 factorial, and then 15 minus 3, which is 12 factorial. And this will reduce down to, or you can plug it in, and you'll get 455. So there's my denominator. So now I have my probability of choosing 5, 7, and 9 is 6 ways to get that 5, 7, and 9, and then 455 ways to get to 3 different pool balls from 1 to 15. And so that's our probability. You can leave it like that. You can go ahead, if you want to, you can leave it as um, a fraction, you can leave it as a decimal, you can leave it as a percentage. All right, so then here's your problem. Same 3 pool balls at random, 1 through 15, okay? And again, uh, what is the probability of choosing first the number 1, choosing first the number 1, then the number 2, then the number 3. So for your numerator, you got to think about, okay, how many choices do you have for the first one? But does order matter, right? If I want 1 first, how many choices do I have? If I want 2 second, how many choices do I have? If I want 3 for third, how many choices do I have? How many choices do I have for each of these? There's your numerator, right? Okay. Your denominator, again, does order matter this time? Does order matter if I want, um, for my numerator, does it matter? Or sorry, my numerator does matter. But what about the denominator? Then the number of 3 balls, right? So my denominator is looking at the number to get 3 pool. So does that order matter if I want those pool balls to be specifically 1, 2, and 3, right? A certain order. Well, that's going to be true as well on the bottom. Order does matter, okay? So order does matter. Okay, go ahead and do this, and that's your last problem for this section.